In this lesson, we're going to be looking at the law of cosines. Law of cosines is used to solve a non-right triangle when two sides and the included angles are given. Included angle is given. So the law of cosine for when we're trying to find the unknown side, for example, in the first equation, A would be the side that we're solving for. We want to take the sum of the square of the other two sides that are given, and then subtract 2 times the product of those two sides times cosine of that included angle. Now, if two sides and the measure of the included angle is known, the area can be found by using the formula that was introduced on the law of sines lesson. 1/2 the product of those two sides, and then times the sine of the included angle. Now, if all three sides are known, the area can be found by using Hero's formula, or it's also known as Heron's formula, and that's the area is equal to the square root of the semiperimeter times the difference of the semiperimeter and one of the sides times the difference of the semiperimeter and the other side times the difference of the semiperimeter and that third side. All right, so in this first example, we want to find AB. We're given two sides and the measure of the included angle. So we're going to use the law of cosines. We're going to square the measure of the two sides that are given, and then subtract the product of those two sides, multiply it by cosine of the included angle. And we simplify the quantity in the brackets, and then subtract them from the square of 28 and 17. We get the approximately 1081.3073, and then to solve for C, we just need to take the square root of both sides, and we'll get approximately 33 for the measure of C. C is the side opposite angle C. All right, now we want to solve this triangle. We're going to start by solving for B. Again, we want to use the law of cosines by squaring the two sides that are given and then adding those quantities together, and then subtracting the product of the two sides, and then multiplying that by multiplying the product of the two sides times the cosine of the included angle. When we do all of those computations, we'll get approximately 475. And then to solve for B, we have to take the square root of that quantity. We get approximately 21.8. So now we know the measure of all three sides. We're going to use the law of sines to find one of the other angles. So I started off with the side that we just calculated, 21.8, which is B. So B over sine of B, angle B is 105, equals lowercase c, which is 15, over sine of C. Cross multiply, solve for C, and we get approximately 41.7 for the measure of C. And then to find A, we just add 105 and 41.7, subtract that from 180, we get approximately 33.3 for the measure of angle A. And then now we have the measure of two sides in the included angle, so we're just going to use the same formula that was introduced in the law of sine and multiply those two sides, and then divide that in half, multiply that quantity by sine of the included angle. We get 47.3 units squared. And then for this problem, we have the measure of all three sides, so we're going to use Hero's formula. First thing we need to calculate is the semiperimeter by adding up all the sides and then dividing that quantity in half. We get 18.5 for the semiperimeter. And so when we set up our equation, it's going to be the square root of the semiperimeter times the semi-perimeter minus one of the sides times the semi-perimeter minus another side times the semi-perimeter minus the third side. And once we do all the computations, we'll get approximately 62.4 units squared for the area.